Hi, this is Steve Palladino at Palladino Power Project, and what I'm going to do today is bring you a couple of ways of doing race power planning using the SuperPower Calculator. Um, First of all, we have a new version of the SuperPower Calculator, version 3, which includes some updates and a section that helps you select the Riegel exponent that you'll use in some of these race power estimations. That's always been sort of a bugaboo for many people. What is my Riegel exponent? Which one works best for me? So we put in some recommendations. So we'll get to that later. But version 3 is the one that you want to be working with for the SuperPower Calculator. The examples that I'm going to bring you today are actually prompted from a Stride community post by one of the Stride users there, where the user had recently, last week as a matter of fact, ran a 5K race in 1644, very nice by the way, ran in 1644 and at a power of 323 watts. The user was doing some race power estimations using the available calculators on the Stride app, and was getting some weird figures, actually powers that were higher than what his 5K power was. And then there's also some prompts, some questions about what his CP was. And here's a little tidbit. If you have recently run a race, then why use that race power to estimate CP and then use the estimated CP to estimate a different race power? Why not just go race power and then estimate a different race power off of that recent race? So you eliminate that middle step of estimating CP where you have some potential error, and then estimating from CP to the race where again you have a little bit of potential error there. Why not eliminate that middle section of calculations? Just go from one race to the other in terms of your calculations. There's a few ways of doing that. We with the SuperPower Calculator, we have a lot of different functions here, and there are different ways, and there are more elaborate ways that I use, such as using the person's prior race power and their weight and their estimated running effectiveness and their Riegel exponent to come out with a race power estimate and also an estimated race time. But there's simpler ways, and that's what I want to get at today. There's some very simple ways. You don't have to necessarily know your running effectiveness, since that's a measure that's not reported in Power Center. Many people don't know what their running effectiveness is for 10,000 meters, or running effectiveness is on this hilly course versus this flat course. So we eliminate that part. It simplifies things a little bit. It may take some of the precision out of the estimate, but still it's very close. So these are a couple of good ways. I'm going to give you two different methods today. So if you go to the drop-down box, there's two methods where you can calculate race target power from a prior race, your target time, in other words, your estimated time for a new race, because it's power duration, so you need the estimated time, and a Riegel exponent. That's one method. Another method that's pretty easy is you calculate your target power using up here, using a prior race the target distance and the Riegel exponent. So two ways. You're using your prior race data, power and duration, or power and distance, and you're targeting a new race, either estimated time or distance, and you need to have a Riegel exponent. So let's go through those. Again, two different methods. Here we are on the main page. We select that particular calculator function, calculate race power from prior race, target distance, and Riegel exponent. So his prior race was 323 watts for 5,000 meters. He wants to know what his power is for 10,000 meters. Here we go, 10,000 meters. All we're doing is entering this. Now, you can toggle over here and you could select kilometers and put in 5 kilometers if you want. I typically just use the meters. And so we'll put 5,000. Oops, sorry. Select meters, 5,000. Also notice on this drop down, you can also select specific. You can select 5K. So I'll do that. 5K, and we'll do 10K. All right, so we've selected those as the race distance and the target distance. Now we need an exponent. Now, what do we use? I have no idea what my exponent is. Well, we put in that help into this calculator. So just click this box, look up Riegel. So what this does is it takes this information and you come over here to the Riegel tab here, and it's going to give you what your data turns up. So actually, let's go back here. I'm going to change this to his actual 1623. 1644, sorry. All right, so power race time. We're going to look up the Riegel, and there we go. So then, hold on. Look it up. All right, so this is not working the way I was working offline, but here's how you use it. We know that he ran a 5K in around 1644. We're looking up a 10K, so we're going to go to Riegel. We look up the target distance, 10K. He ran a 5K in close to 1630. So we're going to go over here, and it suggests that the best option would be minus 0.06. And it's possible that he could be minus 0.05 and minus 0.07. Keep in mind, Riegel exponent is like a fatigue factor. The greater your fatigue resistance, the lower or the more positive the number. So greater fatigue resistance, then maybe this works. Also considering what Riegel exponent is, the target race duration figures into it, and also the difference between the base duration and the target duration, what the difference is. Anyway, we sorted all that out, we put it in here, and so we're going to run this person based on his 5K time, and we're predicting a 10K. We're going to use minus 0.06 for this particular athlete. So we're going to come in here. I'm just going to put in minus 0.06 as the Riegel exponent. And here, as we scroll down, is the target time. 300, about right around 310 watts using this particular method. 310 watts. Now, let's look at a different method. We're going to go to, we're going to calculate race target power using a prior race and what the estimated time is. So we're going to change that. Now, what I did here is all I did is use the Macmillan table to figure out what a ballpark equivalent 10K time is to the 5K time. Macmillan suggests that 34:45, and there's other conversion tables online for time. And the Macmillan tables suggest 34:45 is roughly equivalent to a 16:44 5K time. So I just use that as the estimated target time. So all we need is have a ballpark in here, a ballpark. I mean, it could have been 35 minutes or 34:30, but we're using 34:45 just because we're copying the Macmillan tables. Again, we've already done all the exercise with regard to exponent selection, and we're going to use that same exponent. And now we're going to scroll down, and here's the target. This particular method comes up with a target of 309. So basically what we're seeing is we're seeing a target of around 309 to 310 watts using these two different methods. And that's a pretty tight little window for target power. Now, we could, again, we go back to those other Riegels. Remember, there's, it's possible that minus 0.05 and minus 0.707 are applicable. So I actually did this offline before the video and did the range. So the range, two ranges that we got using those different exponents, or the two methods. We got 306 to 311, 308 to 312 as the target range. So what I would advise this runner to do is target right around 309, 310 watts for his 10K. Again, two methods where you do not have to know your running effectiveness. All you need to know is what your recent race power and duration is, or was, and either your target race distance or a ballpark estimated target time, which you can get from various conversion tables online. Then lastly, you need this exponent, the Riegel exponent, and with this version 3 of the SuperPower Calculator, we have lots of different options to use in providing or coming up with your best Riegel exponent choice to use in the calculator. So hopefully this helps. Get that version 3 of the SuperPower Calculator. Try this out, and happy running. You take care. Bye-bye.